Hey everyone, we're going to take a look at number 5 in section 4.8. This one says to use Newton's method to calculate the first three approximations of the root 21 to the 1/3 power. Okay, let x of 0 equal 3. That's our initial guess there. Use decimal notation. We're going to give our answers to 5 decimal places. Okay, so this is really a neat problem, because the thing is, what is 21 to the 1/3 power? That's the cube root of 21. So if I ask you to find the cube root of 21 without using your cube root or 1/3 power ability in your calculator, how are you going to do it, right? Well, Newton's method is one way to do that. And that was real important, certainly, before the age of computers and calculators, but still very instructive method for us, this numerical method. So how do we proceed? Where do we got to get? Remember, Newton's method was finding the roots of a function, where a function is equal to 0. How do you get x equal, the cube root of 21 to be an equation or a function in some way where we're finding the root of the function? Well, first of all, what I'm going to do is, since x is the cube root of 21, I'm going to cube both sides of this equation. So I get x cubed equals what? 21, right? In other words, if x is the cube root of 21, that means x cubed is 21. And then I'm going to subtract 21 from both sides, right? So I get x cubed minus 21 is 0. Well, guess what? I have an equation set to 0. If I let f of x be x cubed minus 21, I'm literally looking for what? When this function is equal to 0. So I've turned it into a Newton's method problem. Remember Newton's method formula? This is it, right? So what do we need in there to find the next iteration? We're going to start with x of 0 equal to 3. So x of 1, what are we going to need? Well, we're going to need the derivative at one point. Well, that's pretty easy. What's the derivative of x cubed minus 21? Answer 3x squared, right? That's easy. Again, in chapter 4, once again, if you're not finding a derivative at some point, something's wrong. Okay, these are applications of the derivative. All right, so now I just plug in to find x of 1 into Newton's formula. N is 0 here. I get x of 1 is x of 0 minus f of x of 0 over divided by f prime of x of 0. So remember, x of 0 was 3. So that's 3 minus, what would f of 3 be? Well, that would be 3 cubed minus 21. And then f prime of 3 would be 3 times 3 squared. 3 cubed is 27 minus 21 is 6. 3 times 3 squared, or 3 cubed, is 27. And so if you use your calculator to approximate that, you get this rounding off. It's really 2.7 repeating forever, but notice this last one is rounded up to 8. Okay, so there's to 5 decimal places, right? Now, how do I find x of 2? Well, I'm going to plug in x of 1 right into the formula, x of 1 minus f of x of 1 over f prime of x of 1. Now, this is what I get. So how do I do that again? Show you in the calculator. All right, the way we do this, we start with our initial guess, which was 3. So I type in 3, hit enter. Remember, this stores this into the answer variable in the calculator. And so now what I'm going to do to find x of 1, I need x of 0, which is 3, but it's answer in the calculator. So I'm going to say x of 1 is answer, which is x of 0, minus f of answer. What's f of answer? Remember, f of x is x cubed minus 21. So in parentheses, this will be answer cubed minus 21, close parentheses. There's the f of x of 0. And divided by f prime of x of 0. F prime is 3x squared. So divided by, in parentheses, 3 times answer squared. Okay, so again, you have to have the parentheses around your function, and then the parentheses around the derivative. So be real careful about your, using the calculator to do these. So when I hit enter, notice I get the same thing I got here, at least if I round it off to 5 decimal places, right? I would get this. But now, how do I get these? Well, I'm literally going to use the entry command in the calculator, right? Second, press the enter key, which has the entry command above it. It just recopies what I just posted. But now my answer is this. So now I'm going to be plugging in this, right? X of 1, which is this, into the formula. And so if I just hit enter, there's x of 2, right? And here, notice the 5th decimal place is 5. The next one is a 1. So I'm just going to leave that as a 5. What's x of 3? Well, I'm going to use x of 2 and plug that in. So just do second entry again. right? Because now the answer is x sub 2. And so it's going to plug in and get x sub 3. And again, to 5 decimal places, you can see that's what it is. Okay. And there's the result. I just want to keep going a little bit. What is the actual, can we get the best approximation for the cube root of 21, which is what we're doing here? Well, if I go to the 4th iteration, you can see the only difference is way out here in the, I don't know, 1, 2, 3, 4, 5, 6, 7, the 8th decimal place. So we're, at least to 7 decimal places, it looks like we've got it. If I do it one more time and get the 5th iteration, really I don't have any change here in the calculator. Now the decimal places would go on. There's still some round off error in the calculator because we can't go any further in this case. Calculator does store a few more decimal places, but here's the answer we got. Now, how accurate is that? Well, how would you find the cube root of 21? Well, you can use under math, you could use this x root command if you know how to do that, and take the x root of 21, right? Or you can do 21 to the 1/3 power. Right, and that'll be, that's what we started with. And of course, the calculator does. Now, how does the calculator do this? Well, it's got a numerical method very similar to something that we're doing here, right? That's the importance of numerical methods. When you use your calculator to find cube roots and square roots, or the sine of something, cosine of something, or the natural log of something, how's that working? It's a numerical method. Okay. So just keep that in mind. That's real important. We kind of take those things for granted, but we need to understand how those things work. Okay, so at any rate, I hope this is helpful on this one.